relationships between angles and sides of a triangle. So notice angles are still a part of today. And where, with few exceptions, angles either are congruent or add to 180 is still going to be a thing. We're going to be a little more specific with a couple things today. But all the stuff we're going to talk about today is going to revolve around triangles. I'll explain a couple things. It's not too bad. There are three things, though, that I'm going to have you, the three big takeaways that will come out of today. And there will be at least 3 questions one on each of those topics on the test on Tuesday. So this, while it's pretty straightforward, and I actually do believe you know the first thing that I'm going to go over, are pretty basic. It's still something we do need to be alert for come Tuesday. So, today. Hey, look at all those triangles. Oh, aren't they awesome? Look at the little triangles. They're so good. If I had you in class, I would have you all with construction paper, and all of you would cut out a random triangle. That's what I would have you do. And I'd have you do the following. Obviously, I don't have you all in class, so I'm going to show you what I would have you do. But this is what I would have you do all as a whole, because, what I would have you do is first of all, I'm going to turn my dock cam to show you what I would have you do. That would probably help. Full screen. Okay. I would have you take a random piece of paper. Hey, look at this piece of paper. Hey, okay, great. Notice I've cut some stuff. All right, whatever. I would have you all cut a random triangle. So, hey, scissors. Random piece of paper. Let's cut a random triangle. Okay. Now, I'm just cutting this one. Again, it's supposed to be random. It's not supposed to be anything crazy. It just purposefully, I would have every single... Let's get this focus working, please. Stop automatically doing it. Thank you. I would purposely want everyone to do something different because while mine might be a little taller and skinnier, not everyone would do that, and that's kind of the point here. Everyone would have a different size of triangle. But after you all had your different size of triangle, I would say, all right, everybody, label each angle. Just do 1, 2, and 3. So I'm like, all right, I'm going to call this angle 1. I'm going to call this angle 2. I'm going to call this angle 3. Okay? Great, cool. Now what I'm going to have you do after this is I would say, I want everyone to now rip off each individual angle. So like really? Just rip off? Yes, rip off. So okay, so I have my triangle, and there's angle 3, which is right there. Let me rip off angle 2. Okay, and let me rip off angle 1. And then there's the tattered remains of what used to be my triangle. Now, just to confirm that I have done nothing crazy, I want to confirm that, look, they are in fact the same pieces of the triangle. I didn't do anything nuts. I'm not just doing some magic. Oh, look, hey, sleight of hand. Hey, look, hey. I can't do that. Like, little thing, like, can't do that. It's not my thing. Whatever. Anyway, so I'm going to get rid of the tattered remains. And then I'd be like, hey, all of you had a different type of triangle. You all labeled your different angles, and you all tore them up. Hey, now you know what I would like you to do? I'd like you to try and arrange all of your angles into such a way to see if you can make them into a line. And oh my gosh, look at the 3 angles. I have pieced them all together, and they are all adjacent, and they are making a straight line. Dude, wow. And the cool part about this would be like, there'd be 36 different triangles, and 36 of you would be like, oh, we all were able to make them into a line. Isn't that interesting? Huh. So with that, then we go to the part, well, all right, so since all of us had a different triangle, we all ripped off the corner, and we all were able to form them into some sort of a line, shouldn't something be going off in our head about, didn't we talk about angles that made a line that were adjacent to, granted there were only 2 of them, but didn't that mean something to us? And I go, exactly. That's right. Shouldn't that be, yeah, you know what, all that is going to be, these are all the same ideas. Well, wait a minute, they make a straight line, so shouldn't that mean that all those angles make a straight line, so they add to 180? And I go, yeah, that's exactly right. What that introduces, this is just a very simple way. There we go. That's just a very simple way to illustrate what is referred to as the triangle sum theorem. Or, as most of us already know, all the angles in a triangle add up to 180 degrees. Because if you were to rip all of them off, they can form into a straight line. I know, exciting, right? I know most of you probably already are aware of this. If you're not, hey, first thing you need to know, all the angles in a triangle add to 180 degrees. But I'm going to assume the vast majority of us know this already. Great. What are we going to do with this? Well, we're going to just take it to the math 2 level. That doesn't mean anything super crazy. You're still just going to use all the angles in a triangle, add to 180. But what most of us are going to do in this class is we're going to take information from one triangle and probably move it to another. So it's like an application, an additional step. You're good with basics. Let's take the basic and just do one little thing tougher. That's what we're going to do, because it also expands into a few other things we'll talk about in a minute. But as for triangle sum theorem, this is the biggie. The measures of all the angles of a triangle add to 180. Hey, sweet. Piece of cake. How are we going to use this? Well, here's a very simple example. Use the diagram to find the measure of angle MJK. That means that's this angle over here. This is MJK. Right there. Which right now, it is part of a triangle, this one. But I only know this one angle right here. I know the 104. There's something here with an arc mark, but I don't have any information about it yet. So at present, I don't have enough information to solve for the measure of MJK. So what do? Well, in this class, well, looky over here. There's a triangle over here too. And it seems as though I have 2 angle measures of this triangle. Yep, even if I'm lagging with the pen. Oh well. This triangle over here, I know one angle is 88. I know another one is 48. So I can solve for this red angle over here. All the angles add to 180. I take 88. I add 48 to that. 136. And I subtract that from 180 to get the red angle. 180 minus 136 is 44. So this red angle right here is 44 degrees. That's a basic thing. When you first learned all the angles in a triangle add 180, that would be something you'd have to do. Pretty simple. What we're going to do, oh wait, but that still doesn't help us find the measure of this angle all the way over there. So what do? Well, we identify certain things like geometric markings. Arc marks. When arc marks are used consistently throughout a diagram, that means all the measures that are similar to that same arc mark are the same. So like a red singular arc mark, we found out equaled 44 degrees. We use the triangle sum theorem over there. Oh, so every single red arc mark is 44 degrees. Which means that once I solve this to be 44, then this one down here is 44 degrees. And that angle is a part of the triangle that I need to utilize in order to find the angle measure that I need to find. So we're going to make sure we outline the triangle I need to find, or need to use, because the angle I need to find is this one over here in the corner. So 104 plus 44, which is the red arc mark, plus the angle I'm trying to figure out, all add to 180. So sure, here's my basic equation when I write it out really long. The angle I'm trying to find, plus the 2 angles I know, which we said were 104 and 44, add to 180. So I add the 104 and the 44, 148, and I subtract that from 180. Hey, the measure of the angle I'm looking for is 32. There we go. That's how we use triangle sum theorem in this class. We take information from one triangle, we use it in another. And theoretically, I could have you keep going if I really wanted to. Probably not, but... Hey, sidebar. Hey, look at these red arc marks. That means those angles are congruent. Well, I would like to note the location those arc marks are in. A very appropriate question you could ask on a test, perhaps. I don't know if I'm going to do this, but we'll see. Those angles are congruent. Their arc marks say so. Something I would ask a class would be, hey, those red arcs sure appear to be in alternate interior locations, different sides of the transversal, and within 2 lines. So something I should ask my classes is, what does it mean about these two lines right here? And something I could expect out of you is that those lines have to be parallel. If alternate interior angles are congruent, that can only happen if the lines are parallel. Alternate interior angles that are congruent, those lines need to be parallel. Bringing a bunch of things together. Can't information dump. End sidebar. Okay. So let me just do another example with the triangle sum theorem and then show you what else we could do. But after an accident, the positions of cars are measured by law enforcement to investigate the collisions. If you've ever been by an accident site and you see people like rolling around with a stick and a little roller thing and they're rolling it on the ground, what they're doing is measuring how far the skid marks are, because, hey, if I hit a car really hard, it's going to go a long ways. If I hit a car very gently, boop, it's not going to go very far. Conservation of momentum for all those physics people out there. If the car goes a long way, this car that hit it was probably going really fast, which means it was probably breaking the law. And I know a lot of you probably can't drive out there. Hold on. How many people can drive out there? By a thumbs up or something. How many people actually have a license and or permit? So it's me and Miss Murillo. That's it. We're apparently chauffeurs for your entire generation. No one else has a light. Okay. Yes, soon. I know. I know you're all hovering around 15 and a half, borderline 16. Okay. And then some of y'all are babies. Yeah. Some of y'all babies. Exactly. There. I know. You're too old. I understand. I'm too old also. December, 2 more years. Yeah, that's right, because you're 14. I understand that. Fine. Okay. Well, hey, random rule of the road that a lot of people don't realize. Where was that? Okay, good. Some of you are getting them. Okay. I was having this conversation with the class period the other day. It's like, it's totally different. It's generational. Like when you can get your permit at 15 and a half. Exactly. The second I hit 15 and a half, I was at the DMV taking my test. Good, Cody. And the day I turned 16, on my 16th birthday, which was a school day, everyone on your 16th birthday, you would you would ask your parents to not go to school that day, and you'd go to the DMV and you'd get your license that day. Well, assuming you didn't screw up the test. Most people didn't. So yes. So that was a thing. Like, we used to do that. Apparently kids don't care anymore. You'll just Uber all over the place. Great. Whatever. Hey, sidebar though. I know most people don't know this. If you are speeding more than 25 miles an hour over the speed limit, that's a felony. That's a bad type of crime. Most people speeding normally is a misdemeanor, which means you pay a fine and you have to be nice for like 3 years or something like that. Felonies, them bad. You can go to prison for those things. So hey, what'd you learn in math class today? I learned that going 25 miles over the speed limit is a felony. That's bad. So there you go. You learned something. That one you might actually care about. Well, good luck, Evan. Let me know how that works out, man. It's always cool when kids drive. Well, kind of scary. Is it true that when you have your license, if you are... Sorry, now everything is lagging. I apologize. Is it true that when you have your license, if you are driving with someone under 18, you can get your license taken away? I don't think it's taken away. I think there is a suspension thing because I think you're technically probationary until you're 18, I believe is the question. Yeah, exactly. Just make sure you're 24 miles over the limit and you're fine. 24 miles, totally fine. 25 miles, bad. So now all I need to do is teach me how to do taxes. That's easy. You go to, just so you know, most people don't know how to do their taxes. You just enter information on a form. Sidebar. Actually, I was going to do this year. I have been propositioned many times to start what is referred to as Life Club. No one cares about taxes. But let's get this. All right, but for the record, since Elise is really a parent at 14 wants to know how to do taxes. My goodness. Anyway, I have been propositioned many times to start what is. I know that. I know. I've been propositioned many times to start what is referred to as Life Club. Learn those little basic things that people need to know about life. They used to have driver's ed. Driver's ed used to be a thing you could take in school, but they budget cuts. You guys weren't around. So anyway, I was gonna be the advisor for Life Club, and we talked about random things that people actually always claim they needed to learn, like taxes, which is actually a fairly straightforward process, but you have to know what to look for. So like learning about taxes, learning how to vote and signing up and to vote and stuff like that. How to not fight, or how to properly fight. I'm just kidding. I wouldn't do the fighting thing. But like we would talk about certain things like that. How if someone steps on your shoe, that's okay. You don't need to like punch them for that. Yeah, most people said they would. And then I would open it up for certain things because no one cares that the mitochondria is the powerhouse of the cell, but everyone apparently wants to know about freaking how to do their taxes. Okay, whatever. And permit, yes, you have 6 months probation, yes. If you're driving with someone under the age of 18 and there is no one over the age of 18 with a valid license. See, Evan is doing a good job of learning how to get his license. Good job. You've been in that nice little, is it still like a paper, like rectangle like this big? Is it still one of those things that you have to do? Or is it all online now or something? Because when I had it, it was like a paper pamphlet that was this big and this thick. It's online? Okay, that makes sense. Yeah, my mom is an accountant, so she's always done my taxes, but I know how to do taxes. There's actually, here's a random thing that people don't know. Yeah, the permit's still paper. That I understand. Is the underage license still longer this way? Does anyone know if that's correct? Knowing about triangle sum. You will. Oh, and a mortgage. Yeah, mortgage is a big thing. I'm going through a mortgage right now. That's true. The triangle sum theorem is useful, sidebar. And you still get the little certificate. And yeah, okay, cool. That's what I figured. Hey, everyone, I want you to know this. You won't know this until you have to do well, yeah, okay, that makes sense, Evan. You won't know this until you have to buy a house or you're redoing something with a house. But let me tell you how important geometry is. Because right now I'm buying a house. And seriously, I need to know how many square feet of paint I need to buy so I can paint a wall. So I had to redo the flooring upstairs. That's square footage as well. I'm trying to think of a random example when I use the triangle sum theorem in everyday life, but I can't off the top of my head. Nonetheless, but I did in engineering all the time. That was easy. But I'm just saying, geometry is useful. If you actually want to do stuff like that way you don't get ripped off, it helps. So anyway. But yes, driving information, Life Club. When we get back to school, Life Club, we'll do that. Okay. Anyway, hey, sidebar. Triangle sum theorem. I know everyone's excited. This is another legit thing that you could do. Because actually, truth be told, you won't understand this now. But there is a type of mathematics called trigonometry, the mathematics of triangles, trig, T-R-I. And that is how you can calculate certain distances. And if you know certain angles, you can identify certain distances. You know how far certain things are apart. So, yes, you could. But there's more you'd have to do, and you have to be more specific on the type of angle that you were identifying. Because when you get three-dimensional, some angles, how do I do this? So on a two-dimensional scale, that's fine. But when it turns three-dimensional, not only does an angle possibly rotate like this, but it could also go like that. Or the angle could be flipped that direction. So you need to know which plane you are oriented in to find out the angle. So there's more specifics involved with it. So yes, it is a thing you can do, but it requires more specifics. So because when you get three-dimensional, two-dimensional has the XY plane, which is like that. But when you get into a third dimension, there's the Z plane, which comes out you. So it's like that. So it's a three-dimensional plane that kind of looks like that. It's weird. This is the general math gang sign for three-dimensional plane. So I don't know, whatever. Anyway, and only Miss Mario understands what I'm talking about, and that's why she's laughing, and we are lame, because we are going to teach math for a living. Anyway, this is not very hard, because the initial question is asking you to find the measure of XYZ, which is this angle up here in this triangle to the right. So that's not very difficult. I have 62, I have 40, and this unknown angle up here, which I'm trying to find, would all add to 180. So that's not very hard. This is a normal, basic, just learning triangle sum theorem question. That's pretty simple. I add 40 and 62 is 102. I subtract that from 180. Okay, this angle up here is 78. That's not difficult. I'm not saying it is. But what I would ask you in this class wouldn't be to solve for this angle up here. I would instead ask you to find this angle over here in the corner. Come on, there we go. I would ask you to find this angle over here in the corner. How to do that is up to you. Now, a lot of times people will just, and this is the most common, there's nothing wrong with this. Hey, there's a smaller triangle over here. How do I get in from, and that one angle I was trying to find is this leftmost angle over here in this triangle. So I have one angle up here is 12. If I knew this obtuse angle somehow, that would be two of the angles in a triangle. I would then use the triangle sum theorem. So what most people would recognize, and this is the general procedure for most of us, and this is totally fine, is we would recognize that, aside from my computer being laggy, most people would recognize that there is a linear pair here. And if this is 62, I can solve for its angle in my triangle. That's what most of us would recognize. So we use the linear pair. Pretty simple. Oh, okay. The linear pair add to 180. One angle is 62. So I can solve for the other angle by subtracting 62 from 180. So it looks like that angle up there, that obtuse angle, is 118 degrees. Cool. Simple. Oh, and now in my small little triangle, I have two of my angles. I can use the triangle sum theorem. I have 12 up here. Hey, this is still 118. Thank you. So I add 12 and 118, and then I just add those up. 12 and 118, I add those up, I subtract from 180, and I get the measure of the angle I was looking for. It's not the hardest thing in the world. Granted, there's way too much words up here. But you can do that. That's not very hard. I carried information from one triangle to another. Pretty basic. Also, just in case anybody cares, I'm weird. You know, if I was smart, I would just I would just say I'm weird and just move on. But anyway, I'm weird, and that is not how I solved it. What I did was, I'm so used to procedure, and when I see like a multi-step problem, and this goes for like your classwork too, by the way, my brain typically goes like, all right, they are telling me this for a reason. Why would they have me solve for this first? And my brain goes, well, that probably means I have to use that information. So what my brain does is like, all right, I found out that this angle up here is 78. So this one is 78. So I need to use that 78. That's why they told me that. How do I do that? Well, Ariano looks over there and recognizes that there are not one, not two, but three triangles. Three? Three triangles? Yes! This small one on the left, this one on the right, and of course, the entire thing. So I can find out what this angle as a whole is. Oh, very bad version of it. Come on, try again. Lag, 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 lag. So I could find this entire angle because I know this one down here is 40. So if this portion is 78, which I solved for, and I add 12, then this entire angle WYZ, actually turns out to be 90. 40 and 90 add to 130, and then this was the angle I was trying to solve for. 180 minus 130 is still 50. So there are many ways to work with this. It is a thing. That's the general stuff that I expect out of you with triangle sum theorem. Take information from one triangle, move it to another. Now there is something you can expand upon, by the way. It's called the third angles theorem, and it really is just triangle sum theorem. It really is. And it's really straightforward, but here's the deal. if I have two angles over here in one triangle and those exact same two angle measures over here in a different triangle, then the third angles also have to be exactly the same. Here's why. Again, it's just triangle sum theorem. But like, let's say I go over here and I say angle L, which is one arc mark, measures 60 degrees. So L is 60 degrees. That means that R is also 60 degrees because it has that same arc mark. And let's say I say M, which has two arc marks, is 40 degrees. Oh, that means S has the same measure because it has two arc marks. So it is also 40 degrees. So 60 and 40 is 100. That means N has to be 80. Well, then that means T also has to be 80 because they have the same angle measures over here. So the third angles theorem is really basic. In the off chance that you had two angles in one triangle both being the same, or two triangles and two different triangles both being the same, then the third angles also have to be the same. I can make this really complicated and go like, hey, look at that problem over there. Oh my gosh, that looks so tough. And I'm like, no, not really. Not really. Two angles over here are the same. Two angles over here are the same. The ones that aren't labeled, I guess, are labeled with expressions because these two angles are congruent and they're congruent to these same two angles over here. Those third ones marked with expressions, they have to be congruent. So it means their measures are equal. So while it looks really complicated, 2x squared and 4x squared minus 32, what do I do? You set them equal to each other. That's the third angles theorem. Now, I'm not going to make you actually do this math because for whatever reason, even though you can totally do this, by the way, for whatever reason people think this is weird, this is just combining like terms. Your terms are just squared, so I would subtract from both sides and then divide and then take a square root. So just so you know, it's not, you can do this, but the gist of it is, the one thing I want you to know, those third angles are congruent. So that's the main thing. That's all. Triangle sum theorem. So that was a big one. Pausing for questions. Don't worry about it, Jeff. I'm recording. And yes, this is going to be on the test. Not the three-dimensional period or the driving test stuff, but like triangle sum theorem is absolutely going to be on the test. Okay. All right. That was the more in-depth thing. Let's get to the easier stuff. Okay. Simple. Hey, this is a side of a triangle. Hey, this is another side of a triangle. Okay. If the angle in between them is pretty small, the distance between whatever the third side would be, the distance between these two ends, is pretty short. However, as I widen the angle, as I make the angle bigger, then the distance between these two ends, which would be the location of the third side, gets bigger. As the angle gets bigger, the side length gets bigger. As the angle gets smaller, the side length gets smaller. You're like, yeah, thanks, Ariana. Appreciate that. Why? Inside of a triangle, there are basic angle-side relationships. Very basic, like super basic. Like pumpkin spice latte basic. I just offended like 7 people. Miss Maria, do not ever, no pumpkin spice lattes. No. Anyway, they're coming out with those early too. Ugh, gag. This is really simple. Because, you know, it just, this side increases with the angle. The angle-side relationships of triangles are very basic. The largest side of a triangle is always opposite the largest angle. And the smallest side of a triangle is always opposite the smallest angle. And vice versa. And yes, that's it. A small side is opposite a small angle, a big side is opposite a big angle, and it goes in order. So yeah, the middle side is opposite the middle angle, and vice versa. So like something that could happen on your test is they take those angles over there and order them from smallest to largest. Oh no, I don't have the angle measures. Whatever do I do? Well, the smallest angle is opposite the smallest side. The smallest side is GH, so that means that the smallest angle is F. The biggest angle is opposite the biggest side. So this 20.4 is the biggest side. Opposite of that is G. G is the biggest angle. This is not a tough problem. This is not a tough concept. It's actually fairly straightforward. You want to know the toughest thing I can do? Hey, write those sides in order from shortest to longest. Oh no, I only have 2 of the angles. Whatever do I do? And this is where the triangle sum theorem comes into play. Oh, that's right. All the angles in a triangle add 180. So 160, 172. So I can find the other one is 48. So clearly R is the smallest angle. So opposite it is the smallest side. That's how tough I could make this small little angle-side relationship concept. It's really straightforward. It is not supposed to be hard. It's not. Hey, list them in order. Okay, see, and this is where it gets really easy. Okay, fine. Angles from smallest to largest. Smallest side is 9. Opposite of that is B. Angle B is the smallest. Middle one is 15. Opposite of 15 is A. Angle A is the middle one. Largest side is 19.5. Opposite of that is C. Angle C is the smallest. Or biggest, sorry. Ew. Boom. Someone popped in. No. Sad.
Austin, where are you going? He's back.
Who kicked me off? I'm blaming Evan. No? Okay, fine. My bad. Apologies. I don't know what's going on. That's weird. Anyway, this is so basic that I don't even need to be here, apparently. Google said, no, go. So my bad. I'm here, I promise.
Yeah, I see him on the list of people.
I'm here. Hello? Oh.
Really got cut out, yeah.
I'm muted. Aha, I'm back now. Hello.
There we go.
That's right, Miss Maria. It was your time. See? You had one job, and you were supposed to fly into the rescue, cape and all.
Come on now.
Right? Come on. You had jeez.
No.
Fine. Anyway,
Speak for sure, though.
yes, that's exactly right. Okay. Anyway, basic stuff. I'm assuming we all got the angle side relationship. Biggest side, opposite biggest angle. Small side, opposite smallest angle. That was okay. It is that easy. It really is. By the way, that's why when you do Pythagorean theorem, a squared plus b squared is c squared. Hypotenuse is always opposite the biggest side. That's why. Or biggest angle. That's why. Because it's always opposite the right angle. So, yeah. Last thing. Okay. So, if I have a triangle, and I just say like, hey, those are the 3 sides of a triangle. And I say, hey, piece them together to make a triangle. Then you go like, okay, hey, done. Dun, 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 dun. Triangle. Okay. That's pretty simple. However, I need you to go with me on this one.
Are you presenting?
See, here's the good thing. The good thing is that because I'm in the bubble, it is recording the entire time. That's the good thing. The bad thing is, until someone spoke up, I didn't know y'all couldn't see nothing. And I'm just here talking in the bubble, and you're like, what is he doing?
Yeah.
All right, I'm good now. I promise. I might have to restart my computer. Let's try again. Hey, I want those to be the 3 sides of a triangle. Cool. Do. Hey, all right, good. There we go. They made a triangle. All the ends meet like it's supposed to. Cool. Easy. Here's where I need you to go with me. Because again, I'm weird. Okay. Do you remember Meet the Robinsons and the T-Rex? And you know how he's, at one point in time, he's trying to like get to those people, but he's like, oh, my arms are too short. I don't know how well thought through this plan was. Remember that? Okay. So T-Rex has a problem. Really big and scary, right? But like it can't clap its arms. Clap his hands because his arms are too small, because his body's too big. They're like, oh no, bad, oh man. Here's where I'm going with this, and I promise it actually makes some sort of sense. Sort of. Let's say those are now the three sides of my triangle. And I want to go like, okay, so I got to put one there. I got to put one there. And I got to try and make these ends meet, because if it's a triangle, you know, all the ends have to join. No matter how, like, I'm going to try and make these join, but it seems like these two sides are just too small. Like, they're not actually ever going to touch no matter what I do. They have to be bigger. So this is like, these are like the T-Rex arms. Like, they can't, a T-Rex can never be happy because it can never clap its hands. If you're happy and you're, never mind. Anyway, or a T-Rex never knows that it's happy. Whatever. So where I'm going with this is pretty simple. Three sides, three individual segments don't always necessarily are able to make a triangle. Oftentimes they do. But sometimes you can get those little T-Rex arms where they're just like, oh, I just can't meet. It's not going to happen. Oh, no. Oh, no. Yeah. That's an instance right here is when I can have three individual segments, but they don't necessarily make a triangle. How do we know if three segments can make a triangle? It's what's called the triangle inequality theorem. Here's the short version. The technical definition is no one side can be greater than the sum of the other two. That's the technical definition. So what you should do, in theory, is you want to if you want to analyze three segments, right? Can those three segments form a triangle? Or are they going to come up too short like T-Rex arms? In order to find out if they do, you need to take every single combination, every single pair combination, add them together and see if it's bigger than the third. That will take a lot of time. So what I'm just going to tell you to do is really simple. Add up the two smallest sides. If they are bigger than the third side, you're good. If you add up the two smallest sides and they're not bigger than the third, you have T-Rex arms. So, the two smallest sides here are 7 and 10. 7, 10. This means this is my 19. Okay, 19. 7 and 10 they're not bigger than 19. If the two smallest sides are not bigger than the third, you have T-Rex arms. Those three segments cannot make a triangle. T-Rex arms. That's the short version of things. In most scenarios, three segments can make a triangle. Those will all make a triangle. 2.3 plus 3.1 are greater than 4.6. They make a triangle. Now, per the triangle inequality theorem, you're supposed to combine every single pair combination. So you're supposed to say, oh, okay, that's good, but is 2.3 plus 4.6 greater than 3.1? Yeah, of course it is, because 4.6 by itself is bigger than 3.1. So this is kind of dumb. But per the inequality theorem, you do have to check every single combination to prove that every single combination, their sum is greater than the third side. I don't think you have to do that as far as just analyzing if three segments are bigger, or three segments will make a triangle. Just compare the two small ones, make sure it's bigger than the third. There is some use to this, I'll explain in a second. So the two small sides, are they bigger than the third? That's all you really need to check. Now, there's a word I said that's very important. Oh, sorry, before I get to that. This is just a way to make a very simple thing complicated. Oh no, all three sides are represented by an expression. What do I do? Well, you plug in the number they gave you, and then you analyze 10, 15, and 12. Can they make a triangle? What are the two smallest segments? 10 and 12. Oh, 10 plus 12 is 22. Is 22 bigger than 15? Yes. We're good. Again, you're supposed to try all three of them. I don't care. try the two small ones, make sure it's bigger than the third. Now, the word bigger is important because it needs to be bigger than the third. Here I have 8 and 13. 8 plus 13 is 21. 21, oh, and they got to be 21. Oh, okay, they're the same. Hold on. This is the catch. This is the one thing you need to pay attention to. 21 is not bigger than 21. It's a triangle inequality theorem. And you'll notice that if I go back, all the inequality symbols, they don't have equal to signs. There's a reason for that. They need to be bigger than the third side. Because if they just happen to be like, let me make this a little bit bigger, I guess. If they just happen to be slightly this, if they're exactly the same, they're not making a triangle. If they're exactly the same, you have one line directly on top of another line. The two need to be ever so slightly bigger to kind of bow this upward to make it into a triangle. So if it's exactly the same, they don't work. Because it's not a triangle, it's line on top of line. So the one tricky thing that anyone would give you would be this. Oh, they're the same. Well, if they're the same, that's not bigger. So those 3 segments don't make a triangle. They make 2 lines. Those do not work. Again, bigger. So analyzing if 3 sides can make a triangle is pretty basic. Does the 2 sides, are they bigger than the third? That's pretty simple. There's another way to expand with this in which I would give you 2 of the sides and say, okay, you have 2 sides. What range of values could the third side be? So this word range is going to pop up. And by the way, this is the last thing, and then we'll get to our break. That word range will pop up. So you have 2 sides. This is the third side. I'm asking you how, depending on the angle, how small could that third side be? And how big could that third side be? That's what we're looking for. The range of values. What's the highest value? What's the lowest value? Now, the proof to this involves the triangle inequality theorem, which means you would combine every two segment combination and make sure it's bigger than the third. And there's a lot of work that goes with this, and I'm not a huge fan of it because I think that's really complicated. So here's what I'm going to tell you as far as if you need to find a range, here's the basic thing you need to do. It's really simple. If you have 2 sides, to find the biggest distance, add the 2 sides. Oh, 2 sides are 8 and 13. So the biggest side, well, it can't be exactly 21, which is 8 plus 13. Because if it was exactly 21, I would have a line on top of line. So my value has to be just less than 21. So 21 is like my high boundary point. So if I add the 2 sides, that gives me my high boundary point. On the low end, now I just need to fill in this gap. I would subtract the 2 numbers. Now granted, it can't be exactly that number, so 8, 13 minus is 5. Can't be exactly 5, because again, that would be line on top of line. So it needs to be slightly bigger than 5. So if you're ever asked for a range, forget the triangle inequality theorem and all the work that they want you to do. Ain't doing that. Let's make it really simple. Take the 2 sides you know, add them, subtract them, and form them into an inequality. Like so. Oh, wait. So you see here, here's my addition, here's my subtraction, and I just say my values, my range of values are bigger than 5 and less than 21. Add them, subtract them. That's just the easy way to use the triangle inequality theorem. So instead, so again, like, hey, my sides are 22 and 17. I could do all of this work, or I can just go, well, 22 and 17 is 39. 22 minus 17 is 5. So the range of values is bigger than 5, less than 39. That's it.